Hello everybody, welcome to all in my YouTube channel Malabika India. In today's class we're going to read or discuss about the Phaneroxoic orogenic system according to the geological time scale. So before going to the discussion, I'd like to say this is a very important topic in UGC NET syllabus, because geological time scale, there is a lots of question is coming in every year in this geological time scale from this chapter. So before going to the detailed topic, we'd like to discuss about the geological time scale. Okay, so first we will divide this total geological time scale according to this division. The major division is eon, then comes to era, then period, then epoch, and years before present. This is the years according to which these all epoch periods are divided. Okay, so we will go from the oldest to the newest. For that we'll focus on it. You can see the eon, that is the major division, is divided into these four types. The oldest is Hadean. This continues from 4.8 billion year to 3.8 billion year. This is the time when the earth actually created. Okay. After that, Archean period, Archean eon, 3.8 billion year to 2.5 billion year. Then Proterozoic, that means the Precambrian time, 2.5 billion year to 570 million year. And after that comes to Phaneroxoic, from when the life is actually created. This is the time of creation of life. So 570 million year to till now. So eon is divided into this. That means the major division is four. Now our present discussion, or our today's discussion, is about this Phaneroxoic orogenic period. After that comes to this Proterozoic period, Precambrian time, and it is all about 2 billion years before present. BP, you can see that BP, that means before present. Then this Phaneroxoic eon. Phaneroxoic eon is further divided into this three era. That is, the oldest one is Paleozoic, then comes to Mesozoic, then comes to Cenozoic. So this Paleozoic era is further divided into this period, that is Cambrian. We will go from this to this because the direction of the period is from lower portion to the upper portion. I can draw here an arrow, that is, this arrow goes to the upper portion. Okay, this is the direction basically. So Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian. You can see here the time. That means at about 570, I actually said before that 570 million year to till now, that is approximately 600 million year to 500, that is Cambrian, 500 to 425 Ordovician, 425 to 405 Silurian, 405 to 345 Devonian, 345 to 280 Carboniferous, 280 to 230 million year Permian. After that, Mesozoic era. This is further divided into these three periods, that is Triassic, 230 to 180 million year, then Jurassic, 180 to 135 million year, then Cretaceous, 135 to 63 million year. Then comes to Cenozoic era. That Cenozoic era is actually divided into this two period. Okay, one is tertiary period and second one is quaternary period, and this quaternary period is the most present period. Actually we are going through this period because it is Holocene epoch. We are going through this. Now this tertiary period is further divided into this epoch, that is Paleocene, 63 to 58, Eocene, 58 to 36, Oligocene, 36 to 25, Miocene, 25 to 15 million years, Pliocene, 15 to 1 million years. Okay, now comes to Quaternary. Quaternary is further divided into these two epochs, that is Pleistocene and Holocene. So the Pleistocene is from 1 million to 10,000 years, and Holocene is 10,000 years to till now. Present is, it is also actually going on now, present. Now we'll go for the detailed discussion. You can see here explanation in brief about this topic. So this Phanerozoic orogenic belt that spans of combination of the Paleozoic, Mesozoic and Cenozoic that I already discussed in this chart or table. This Phanerozoic orogenic belt is further divided into these 4 orogenic. You can see here, I have already written it out. So this 4 orogenic belt. Number 1 is Appalachian Caledonian. It is situated in the eastern North America to western Europe. Then comes to Hercynian, Central Europe, Cordilleran along the Pacific Basin, and Alpine Tethyan, that is from western Europe to Southeast Asia. If you just consider, or if you just think the total earth, you can easily understand this. Like in extreme west, there is North America to covering the Atlantic Ocean, western Europe. We'll go from North America to western Europe. Total, we can see that Appalachian Caledonian orogenic belt. After we comes to Central Europe, the main European part, that is actually under the Hercynian orogenic belt. Then comes to Pacific Ocean. We can see this is under the Cordilleran orogenic belt. And if we concentrate about the Western Europe to Southeast Asia, that means the southern portion oblique from Western Europe to the Southeast Asia, this is under the Alpine Tethyan orogenic belt. Okay. And these all orogenic belts are under the convergent plate boundaries. Now we will discuss about the total continental changes, the formation of the continental plates along or according to the this period, geological period. Okay, first we will discuss about the late Precambrian to early Cambrian. Okay, by 1,000 million years ago, there is almost 3 or more supercontinents in the total earth, but these continents started to fragmentation during late Precambrian period. First, Laurasia splits into Laurentia, Baltica, Siberia, Kazakhstania, China. Okay, in early Cambrian period. Then we'll come to late Cambrian and Ordovician. According to the paleological data, if we see all the paleological data, past data, we can see that these all the continents were concentrated along the low latitudinal area. Like if we just draw here a earth, and if we, by my earth is too bad. So, and if this is the equatorial line, we can see that all the continents are concentrated within this area. This is the low latitude area. That means the area along or near the equator region, that is the low latitudinal region. Now, these convergent boundaries existed along number 1, northeastern coast of Laurasia. Just see, this is the Laurasia part, this is Baltica, this is Gondwana land, Siberia, Kazakhstania, Australia, America and China. Okay, so the first convergent plate boundary is situated near the northeastern, that means this is the eastern part and this is the north. So northeastern part of Laurasia. Then western coast of Baltica, that means along this region. Then southwestern margin of Siberia, Siberia southwestern, that means this portion. Then eastern and western part of Kazakhstania, and eastern Australia, New Zealand and Antarctica portion of Gondwana land, that means Gondwana land portion. Here another orogenic belt is, or the convergent plate boundary is situated. Then comes to middle Ordovician. Now at the Cambrian or late Cambrian period, we have already discussed that Laurasia started to fragmentation. Now Gondwana land also started to split out. It actually moves from upper portion to the south pole portion. It started to move towards the south pole, and caused glaciation in Africa. It is quite natural that if the total Gondwana land goes towards the south pole, the glaciation is obvious, because south pole is the region where the now at present Antarctica is situated. So as we can see that Antarctica is completely under glaciation, so obviously at that time Africa was under glaciation. This is a quite natural things. And Laurasia undergoes counterclockwise rotation and remains in a low latitude. So obviously Laurasia started to move counterclockwise, that means against the clockwise direction, counterclockwise rotation, and remains in the low latitude. But Laurasia moves a counterclockwise direction towards the southward, towards the south pole, but still it remains in a low latitude region, that means near the equatorial region. Then comes to Silurian period. In Silurian period, Baltica and Siberia move towards Laurasia. that means Baltica, Siberia, which were Baltica in the southern portion, Siberia in the northern portion of along to Laurasia, but both of these continents started to move towards Laurasia, and Gondwana land centered over the southern pole. At this time, seafloor spreading and oceanic ridge system started to create, and two subduction zone. One is Cambro-Ordovician subduction zone and another was Antarctica Australia subduction zone. These both started to extend along the western margin of South America. So it actually started to extend or moves along the western margin of South America. Very important. Another subduction zone, this is active subduction zone, lengthened along the margin of Ipetas Ocean between Laurasia and Siberia. You can easily understand that. Like you can see, there's a big gap in between Laurasia and Baltica. Okay, so this gap creates the Ipetas Ocean. But during the Silurian period, when the subduction zone between them started to lengthen up, so these two gap, that means this Ipetas Ocean in between this Baltica and Laurasia started to close up. Okay, and for that, in Devonian period, we can see that Ipetas Ocean actually completely closed, so automatically resulting to orogenic collision in between northern Europe and eastern North America. This is the common result if the two continents in between the ocean of between two continents closed up. So obviously two continents will become closure and there is an orogenic collision is created, and this is actually happens in between northern Europe and eastern North America. And another convergent plate boundary initiated along the northeastern and southeastern coast of Baltica. That means in the period of Cambrian period, late Cambrian period and Ordovician period, we already have seen that in the western coast of Baltica there is a convergent plate boundary, and in Devonian period another convergent plate boundary is created along the total eastern side, that means northeastern and southeastern part of Baltica. Now we will discuss about the Carboniferous period. The collision in between Laurasia and Gondwana land produced Hercynian orogeny. This is quite natural. You can see that all the continents of Laurasia, Gondwana land all comes closer along this region. That means low latitude region to southern pole. So obviously there is a collision is quite natural in between Laurasia and Gondwana land, and this is as a result of this collision in between Laurasia and Gondwana, the Hercynian orogeny has been created. And Kazakhstania collides with Siberia. So due to this two collision, supercontinent, that means Pangaea is created, and as a result of creation of Pangaea, obviously Panthalassa is also created. You can see this is the Pangaea supercontinent and this is the Panthalassa superoceanic continent. I mean superoceanic land part of the earth. Now in this time, Tethys Sea also creates in between Laurasia and Gondwana land. Tethys Sea, existence of Tethys Sea is created in between Laurasia and Gondwana land. Then we discuss about the Permian period. From Gondwana land, Tibet, Iran and Turkey was drifted away. It separated, started to separate from Gondwana land in Permian period. Then, obviously as the total Gondwana land moved toward the south pole, so obviously as we can say, understand that all the glaciation started, because in Africa already the glaciation was done, and other parts of Gondwana land will obviously be under the glaciation period at that time. But as the creation, as the Hercynian orogenic belt was created in between Laurasia and Gondwana land, so the moist air of the Gondwana land cannot be able to reach towards the Laurasia, because orogenic belt, actually we all know that orogenic belt, that means it is the creation of fold, fault, etc. mountain, basically fold mountains. So due to Hercynian orogenic belt, there is a huge fold mountain. It has been created in between Laurasia Gondwana part. So the moist air from the Gondwana land are not been able to reach the Laurasia Baltica part. So obviously as a consequence, the Laurasia Gondwana part become dry. So this is the result here. After that we discuss about the late Permian period and Triassic period. You can see that Laurasia started to move toward northward relative to Baltica. So that means Laurasia moved toward northward relative to the Baltica. Siberia collides with Baltica and China, and Ural mountain created because Baltica Kazakhstania continent started to collide with Siberia. Siberia collide with Baltica, China, so obviously Baltica and Kazakhstania collide with Siberia, and due to that Ural mountain has been created in between that region or in between that continent. Pangaea started to break up. And China Malaya collides with Laurasia. So there is a huge collision has been created in between Laurasian part in this period, late Permian and Triassic period. After that comes to Jurassic. North America and Africa rifted apart, and that's why North Atlantic Ocean begins to open. You can see this picture. The North America and Africa and South America, they all are connected with Africa. When in Jurassic period North America started to being rifted apart from Africa, the North Atlantic basin has been created, and when the South America has been rifted from Africa, the South Atlantic basin has been created. So it is a quite simple explanation which had occurred in the Jurassic period. So in the middle to the late Jurassic, Africa rifted away from India, Antarctica. Africa is also rifted apart from India, Antarctica. South Atlantic, as I've already said, that South Atlantic basins opens from Africa when Africa is rifted away from South America. So you can, I have already discussed about it, that South Atlantic begins when South America rifted from Africa, and North Atlantic begins when North America rifted from Africa. Western Arctic Basin. Now we'll discuss about the Arctic Basin. Western Arctic Basins opens up when Alaska started to move towards western portion from Canada. From it actually being rifted from Canada and moves towards west. So obviously the Western Arctic Basin has been created. And when Spain rotates counterclockwise from Europe, the Bay of Biscay has been created. Now we will discuss about the Cretaceous period. In Cretaceous period, first Labrador Sea begins to open as Greenland moves from North America in eastward direction. Greenland moves from North America from eastward direction, and that's why Labrador Sea, in between them Labrador Sea opens up. And Africa continues to move in a counterclockwise direction, so that's why Tethys Sea open in between Africa and Eurasia. Africa started to move in a counterclockwise direction relative to Eurasia. So that's why in between Eurasia and Africa, Tethys Sea opens up. And as the Greenland moves from North America in an eastward direction, so that's why in between Greenland and North America, Labrador Sea opens up. North Africa also collides with Eurasia. African northern part of Africa is collide with Eurasia, and South Africa becomes to create a wider ocean, because it's quite natural when the Africa is moving towards a counterclockwise direction. So that means it is also drifting apart from South America, and it is actually being open up in the portion of it actually creating an open ocean from Atlantic Ocean, opening up in front of Atlantic Ocean, Indian Ocean. In both the ocean are actually being created. That means South African part is actually being open up into this in front of this two ocean. So and North Africa is colliding with Eurasia. So as a consequence, we can see that Madagascar reaches its present position relative to Africa. Madagascar continent is also being created during this period, and India begins northward motion towards Asia. That means India is also colliding with Eurasia or Asia, basically Asia, because India is moving towards northward direction. So this is the structure. We can see that in late Cretaceous structural reconstruction during this late Cretaceous period, this kind of landform or continental situation was this kind of. After that, Tertiary period, because in Tertiary period, Himalayan mountain, Alps mountain, these all new fold mountain has been created from Tethys Sea. So North Atlantic between Greenland and Norway begins to open up, and Eastern Atlantic basin opens, because when Greenland and Norway started to drifted apart. Norway from Europe and Greenland from North America, and also in between these two regions, that means here is Norway and here is Greenland, and this in between two regions the Eastern Atlantic basin started to open up. About 35 million years ago, India started to collide with Tibet, and in under the Indian Sea, Carlsberg Ridge. This is the most important ridge under the Indian Ocean. So that's created at about 35 million years ago. And New Zealand started to drift from this Australia, and as a consequence of that, Tasman Sea has been opens up in between New Zealand and Australia. Remnants of Tethys Sea, as we all know that at present time Tethys Sea is not existing, and in place of Tethys Sea, Himalayan mountain, Alps mountain are all there. So in between in replacement of Tethys Sea, we as a remnant, we can say as a remnant, Mediterranean Sea, Black Sea and Caspian Sea all are present nowadays. And South America started to separate from Antarctica. South America started to separate from Antarctica because at that time, before this time, I mean before tertiary period, South America is connected with Antarctica. Australia was also connected with Antarctica, but South America started to drifted about from Antarctica, and also Australia drifted from Antarctica. Like you can see that Australia drifted from Antarctica and moves northward. Obviously, they both moves northward. And beginning about 30 million years ago, basin and all reach provinces, that means basin and reach system has been created in this period. East African Rift Valley system created. Red Sea opens up and Iceland begins to rise on mid-Atlantic ridge system. And last 10 million years, we can see that Pacific basin, the spreading direction of Pacific basin has been changed towards the westward direction. Because before this time, the direction of the movement of Pacific basin was another, I mean in another direction. But after during this last 10 million years from that time, the Pacific basin started to move towards westward direction. The plate of the Pacific basin started to move towards westward direction. Gulf of Aden completely opens up. Gulf of California opens up because San Andreas transform fault system migrates southward. As we can see that California Gulf was created in between California and the western part of North America, southwestern part of North America. And because along this region, San Andreas transform fault is situated, and this fault is actually moving towards the southward direction, and this is the main reason of the creation of Gulf of California. So that's it. This is the main topic of our today's discussion. You can see that I have prepared a notes for you, and this is really gonna be useful for you all. So please check it out. And if there is any kinds of query regarding this topic, you can ask me in comment section. Okay. And the next topic, what you want to read or want to know from me, you can also read it in the comment section. I will obviously try to prepare a notes and also to know you all, give the knowledge about this topic to you all. And till then, thank you so much. Bye bye.